Hi, welcome to my video on the motion of a particle on a line. In this video we're going to compare the motion to a parabola. Comparing the motion of a particle on a straight line to the graph of a parabola. Let's look at the parabola first, which is y equals x squared minus 6x plus 5. And notice that this parabola, this is positive, so the parabola is going to open upward. But if we did y prime, we would find that we have derivative of x squared is 2x, the derivative of a negative 6x is negative 6, and the derivative of 5 is 0. So that means if we make y prime equal to 0, we have 2x minus 6 equal to 0. 2x is equal to 6, so x equals 3. And so the derivative, y prime equals 0, that's when the slope of the tangent is 0. So the slope of the tangent is equal to 0 when x is 3. And we plug that back into the equation, put 3 in, and work it out. We get a 9 minus 18 plus 5, negative 9. So that would give us a negative 4. So this point, 3, negative 4, is the vertex of the parabola. So 3, negative 4 here is the vertex of the parabola. And if we let x equals 0, put a 0 in here, we get 0 squared is 0, so we get y is 5. So that's 0, 5. So letting x equals 0, we have y is 5, so that's the parabola which has an, I should say a y-intercept of 5. We got a vertex here, so that means it's opening downward. So that means it's coming down through here, and so it's doing this, and then it's going to open up, and like that. And so by solving this and letting, again, if you let y equals 0, you have x squared minus 6x plus 5 equals 0. So x minus 5, x minus 1 is the factorization. So when x is 5 or when x is 1, we have the y 0. So 5 comma 0 and 1 comma 0 are the x-intercepts. So they pass through right here and right here. So there's the equation of the parabola, and notice by doing the derivative we got the vertex is at 3, negative 4. Now let's compare this parabola to the position of a particle on a straight line. So if we let t equals 0, so the s of 0 is, again, put a 0 here and a 0 here, we would get a 5. So that means when t is 0, the particle is starting off right here at 5. Now, what happens, again, it's very, very similar, and we do the derivative of the f prime t, and the derivative is 2t, derivative of x squared, or t squared is 2t, and derivative of negative 6t is negative 6, derivative of 5 is 0, so we get the derivative, and in this case position, this is the velocity, because the derivative of the position curve is equal to the velocity. So the velocity is equal to 0 when 2t minus 6 equals 0, 2t equals 6 when t is 3. So when t is 3, that gives us, if we again plug this point in, we're plugging it into here. So if we take this point and sub it in right here, which is, if so, if I go right across from here and say t is 3 and sub that into the t of 3, without writing all that down, I would get a negative 4. So when t is 3, I have a negative 4. So when t is 3, I have a negative 4. So as you can see, right here at 5 is coming down, hitting the minimum point and going back up. So what happens is that as it's coming down, the particle gets hit. At this point, the particle will stop temporarily and go back up. So on the way down, the particle has to slow down to come to a stop, and then after this, it speeds up. So in relation to this, if I did the derivative of, if I did t double prime, that would be the derivative of the velocity, which is the acceleration. So t double prime. So if I take t prime, which is the velocity, and do the derivative of 2t is 2. Derivative of negative 6 is 0. So the acceleration is always a positive 2, which means that in relation to the parabola at 2 seconds, or at any time, I should say, not at 2 seconds, the acceleration is 2. So that's 2 meters per second squared. And this is the velocity, which is meters per second. So at any time, the acceleration is always the 2. So no matter what time the acceleration is always the 2. So that means it's always moving to the, if you think of it, it's always like concavity. This is positive, it's opening upward. So it's always a positive. So that explains an acceleration. Again, we have at 3. So if you look at it, at 0 and at 3, if you take, it starts here at 5, it goes over to 4, which is right here, and then it stops. And that means because it stops, it's going to go backwards. It's not going to go, not backwards, it's going to go back. So notice this is swinging to the left. So if we take the s prime and look at 2t plus 6, that means that 2t plus 6 is greater than 0. 2t is greater than 6. So when t is greater than 3, that means it's going to go, t is greater than 3 is going to go to the right. So here is it at 3. So at 3 it stops. And when t is greater than 3, then it swings to the right. And also, if you let your acceleration, you let your velocity, s prime, which is 2t minus 6, so if you let 2t minus 6 be less than 0, 2t is less than 6, t is less than 3, and time 0 is less than 3, less than t, less than 3. So greater than 3 is going to the right. That means between 0 and 3, it's going to go to the left. So between 0 and 3 seconds, it's going to go left from 5 down to, I said 4 here, no, that's a negative 4. 3 gives us a negative 4, that's a negative 4 distance. And this is, as you can see that here in the parabola. So from x is 0 to x is 3, it's going down, so similar to going left here. And after 3, it's going up. So that means up, again, is to the right. So that's explaining about the velocity and acceleration in relation to this parabola. Again, very, very similar, only sometimes can be confusing. And again, if you like my video, click the like button, click the subscribe button, visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content that's on my YouTube channel called Math Fully Explained, just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.